Welcome everyone. I'm Majid and you're watching Lucid Mind. Today we'll solve paper 12 from March 2025. Let's start. Question 1. A Boltzmann distribution for a sample of reacting gas at constant temperature is shown. The activation energy for the reaction is marked. We can see this is activation energy on the x-axis. Point X shows the number of particles whose energy is equal to the activation energy. Here we can see that this is equal. The temperature of the sample is decreased. The shape changes. Which point could show the number of particles whose energy is the same as activation energy at new temperature? Now we have 4 points A, B, C and D. A and C are actually wrong. This is because activation energy can neither be increased nor decreased by change in temperature. So we only have 2 points B and D. Now when temperature is decreased, what happens? The height of the hump, it increases and it goes a little bit to the left. So it goes through point D. So at point D we can see now we have new number of particles whose activation energy is equal to EA given. Point B was possible if the temperature was increased. So when temperature is increased, the height of the curve decreases and it will go through like this. So this is at higher temperature. This is at lower temperature. And this is the one which is given. So correct answer is D. Question 2. Crystals of copper to nitrate are prepared by adding an excess of malachite to nitric acid. The formula of malachite is CuOH2, CuCO3, whose MR is given 221. 12 grams of malachite is added to 30 centimeter cube of 1.5 mole per decimeter cube nitric acid. Which mass of malachite is left unreacted when the reaction is complete? So now it means that malachite is in excess and nitric acid is the limiting reagent. Let's first find out the moles of nitric acid which are given. So we have 30 centimeter cube of 1.5 mole per decimeter cube. Moles equals to concentration into volume in decimeter cube. Concentration is 1.5, volume is 30. Converting it to decimeter cube, we have to divide by 1000. So the number of moles is 0.045 moles. These are the moles of nitric acid. Now let's write down the equation of malachite with nitric acid. So we have CuOH2 dot CuCO3 plus HNO3. Now we can see in the formula of malachite we have two compounds. One is copper hydroxide, second is copper nitrate. So both can react with nitric acid separately. When copper hydroxide, which is a base, it reacts with acid, it forms salt and water. So let's first write down the equation of these two. So it will form copper nitrate plus water. Second one is the reaction of carbonate with nitric acid. So when carbonate reacts, it forms salt, water and carbon dioxide. So salt formed will be again copper nitrate plus water plus CO2. Okay, now let's try to balance the equation. We have 2 copper and 2 copper on the product side, so it is balanced. Then we can say we have nitrate. So there are 2 nitrate and 2 nitrate. In total we have 4. So we can write 4 with nitric acid. Now let's balance hydrogen. So we have 2 hydrogen atoms and 4. So it becomes 6 on the reactant side. We have 4 on the product side. So we can make any one of them 2. So let's make this 2. Now we have 6 atoms of hydrogen. Last one is oxygen. So we have 3 and 2, 5 plus 12, 17 oxygens on the reactant side. And we have 6 and 6, 12, 13, 14, 15, 16, 17. So now the equation is fully balanced. From equation we can see we have malachite ratio nitric acid. So the balanced equation says that it is 1:4. We have 0.045 moles of nitric acid. So 0.045. Let's find out how much malachite is needed to react with this. So we can cross multiply, find the value of X, where X is the moles of malachite. So it is 0.01125. Let's convert this moles into mass. We can see from the question MR is given 221. So mass is equal to moles into MR. This is moles. 221 is the MR. So it comes equal to 2.486 grams. In the question, they said that 12 grams of malachite was actually used. Now we have to find out how much is left unreacted. So we can subtract this by the reacted amount. So 12 grams minus 2.486. This one is equal to 9.51 grams. So correct answer is D. Question number 3. X and Y are elements from the same group of the periodic table. 5th to 9th ionization energies are shown. We can see these are the values of ionization energies. Which row identifies element X and element Y? Okay, so we can find out the group number by looking at the ionization energy values. We have 11,000, 15,000, 17,000 and then 92,000. So there is a huge jump from 7th to 8th ionization energy. It means that the 8th electron is present in the inner shell as compared to the 7th electron which is present in the outer shell. So if there are 7 electrons in the outer shell, it means this element X, it belongs to group number 7, which is halogens. Now looking at element Y, we have 6,000, 9,000, 11,000, 33,000. So again we can see there is a huge jump from 11,000 to 33,000. So there are 7 electrons in the outermost shell of element Y. So Y is also from group number 7. Let's look at the given options. We have argon, chlorine, fluorine, neon. Now argon belongs to group number 8, neon belongs to group number 8. So A and D are wrong. In B and C we have chlorine and fluorine and fluorine and chlorine. Let's see which one is element X and which one is element Y. Now we know that in group 7, as we move down, the size of atoms increases. Number of shells also increase. So the outermost electron, it becomes further from the nucleus. It is easier to remove outermost electron. So ionization energy values decrease down the group. So as in group we have fluorine, then chlorine. So it means chlorine has lesser ionization energy value for same electron as compared to fluorine. So we have 11,000 and 17,000. This 11,000 must be chlorine and this must be fluorine. So X is fluorine and Y is chlorine. Correct answer is C. Question 4. An ion with a charge of 2- contains 10 electrons and 14 neutrons. What is its nucleon number? This is a very simple question. Let's suppose the element is A. It has got a charge of 2-. So now after 2- it has 10 electrons. So it means neutral A would have 8 electrons or 8 protons. So if protons is 8 and neutrons is 14, we know that nucleon number means protons plus neutrons. So protons is 8, neutrons is 14, so nucleon number becomes 22. Correct answer is B. Question number 5. The structure of the hormone histamine is shown. This is histamine. Which row contains the bond angles X, Y, and Z in the correct order from smallest to largest? Let's find out about X, Y, and Z bond angles. Now starting with X, we can see we have nitrogen. Nitrogen is making 3 single covalent bonds. Nitrogen belongs to group number 5 of the periodic table. So it has 5 electrons, out of which 1 is lone pair, and there are 3 bond pairs. Now this is similar to ammonia. In ammonia also we have 3 bond pairs with 3 hydrogen atoms and 1 lone pair. The bond angle in ammonia is 107 degrees. So this X bond angle must also be similar to 107. Second one is carbon. Carbon is making 4 single covalent bonds. There are no lone pairs present on carbon as it has only 4 electrons in the outermost shell, all of which are making bonds. So this one is similar to CH4, where carbon does not have any lone pair and 4 bond pairs. So the bond angle in CH4, as it is tetrahedral, so it is 109.5. So that's what Y should be. It should be 109.5. Third one is carbon. In Z, we have the carbon making 3 bonds and no lone pair is present. So whenever an element with 3 bond pairs and 0 lone pair, the bond angle could be 120 degrees. So this one is similar to BF3. In boron trifluoride, boron has no lone pairs and 3 bond pairs. Now boron makes 3 single covalent bonds, but this carbon is making a double bond. Always remember that in bond angles, single bond behaves as double bond. There is no change if double bond is present or single bond is present. So BF3 has 120 degrees bond angle. This one would also be 120 degrees. So 107 to 109 to 120. So X, then Y, then Z. Correct answer is A. Question number 6. When an organic acid reacts with an alcohol, a reversible reaction takes place producing an ester and water. 0.4 moles of an organic acid and 0.3 moles of an alcohol are mixed and allowed to stand at 25 degrees Celsius until equilibrium is reached. At equilibrium, 0.2 moles of ester is produced. What is the value of equilibrium constant Kc under the conditions used? Let's first find out the balanced equation for the reaction of organic acid with alcohol. So we can take the simplest acid, which is methanoic acid, 1 carbon carboxylic acid, HCOOH, and 1 carbon alcohol, methanol, CH3OH. So the reaction is reversible, double arrows. Now ester is formed, HCOOCH3, and we have water. Now if you look at the equation, it seems balanced already. We have 1:1, 1:1. 1. So this part is acid, this one is alcohol, then we have ester and water. Now from the question we can see we have initial moles, which is 0.4 for acid and 0.3 for alcohol. (0.4), 0.3. The reaction has not started, so amount of product formed is 0. Then it says that at equilibrium 0.2 moles of ester is produced. So then we have change and we have equilibrium. At equilibrium 0.2 moles of ester is formed, so this one is 0.2. Alright, so let's put the other values. We have 1:1 for ester and water, so it means same moles of water must also be produced, 0.2. Alright, now we can find out the change from 0 to 0.2. The change should be plus 0.2. As it has increased, same change is for water because the ratio is 1:1. And as this one is also 1, so the change should be similar. But the reactants decrease and the products increase, so sign for reactant should be negative. Let's find out the equilibrium moles. So 0.4 minus 0.2, 0.2 is left. 0.3 minus 0.2, 0.1 is left. All of them are moles and this is the same reaction in the same container. So number of moles and concentration is the same thing. Now let's find out Kc. So according to formula, Kc is equal to the concentration of products, which is ester and water, divided by concentration of reactants, which is acid and alcohol. So we have 0.2 concentration of ester, 0.2 concentration of water, 0.2 concentration of acid, and 0.1 concentration of alcohol. We can then find out the answer, so it is equal to 2. Correct answer is therefore C. Question 7. Information about two substances is given. One is P, one is Q. First thing is the electrical conductivity. P is good when solid and when molten. P reacts vigorously to produce an alkaline solution and its melting point is 454. Q does not conduct in any state. It reacts vigorously to produce an acidic solution and melting point is 317. We have to find out the structure and bonding in substance P and Q. So whenever a substance is good when solid and good when molten, it means it should be the metal. And it says Q does not conduct in any state, so non-metals are those substances that does not conduct in solid or liquid form. Then it says it reacts vigorously to produce alkaline solution. So if this is a metal and it reacts, so it could be alkali metal. And this one reacts to produce an acidic solution, so obviously it's a non-metal. Phosphorus, sulfur, etc. they are non-metals and form acidic solutions. So P is metallic or ionic or metallic or molecular. So metallic seems right. Simple molecular is for non-metals. Giant ionic is bad conductor in solid form. So Q is simple molecular or giant ionic. Now Q does not conduct in any state, so it cannot be giant ionic. so it should be simple molecular. So correct answer is A. Question 8. An excess of zinc reacts with X centimeter cube of 2.00 moles per decimeter cube HCl. The gas produced is dried and collected, so we do not have any water molecules present. The gas occupies 1.534 decimeter cube at 101,000 pascals and 293 Kelvin temperature. The gas produced behaves as an ideal gas. What is the value of X? So we have to find out what is the volume of this HCl which has reacted with excess zinc. Let's first write down the balanced equation. So we have zinc, Zn, reacts with HCl. So metal plus acid forms salt, zinc chloride, and releases hydrogen gas, H2. We have Zn balanced, chlorine is 2, so we can write 2 over here, hydrogen is also balanced. So as in the question, they have given zinc in excess, so this is excess, so it means hydrogen is dependent on HCl, which is the limiting reagent. We have 2:1 according to balanced equation. So we do not have moles for hydrogen. First, let's find out the moles from the given data. We can use ideal gas equation, PV equals to nRT. P is the pressure, V is the volume, N is the number of moles, R is ideal gas constant, and T is the temperature. We need to find moles, so we can separate N. N will be PV over RT. Let's put in values. So pressure must be in pascals. It is already given in pascals, so we have 101,000. Volume must be in meter cube. This is decimeter cube, so we can convert this into meter cube by dividing by 1000. So if we divide this by 1000, it becomes 1.534 into 10 raised to the power minus 3. Then we have R, whose value is 8.31. It is given at the last page of the paper. And then we have temperature, that should be in Kelvin. It is already in Kelvin, so 293. Let's find out moles. So it comes equal to 154.934 divided by 2434.83. So it is 0.0636 moles of H2. Now from balanced equation, we can find out the moles of HCl used. Let's cross multiply. So it is 0.12726. These are the moles of HCl. We need volume, we have concentration, we have moles. So volume equals to number of moles divided by concentration in decimeter cube. So let's put values. Number of moles is 0.12726. Concentration in decimeter cube is 2. So the volume in decimeter cube will be 0.0636. Answers are given in centimeter cube, so now we can convert this into centimeter cube by multiplying by 1000. So 0.0636 into 1000. 63.6 centimeter cube. Correct answer is therefore C. Question 9. An aqueous solution of hydrogen peroxide is placed in a flask and decomposes as shown. The total volume of oxygen gas evolved is 180 centimeter cube after 90 seconds, measured under room conditions. The rate of reaction is calculated using the equation rate equals to change in moles divided by time. What is the average rate of the reaction measured in moles per minute over the duration of the experiment? Okay, so the rate is equal to the change in moles of H2O2. So we have to find out the moles of H2O2 and we have to find out the time in minutes. We can divide those two and we have the answer. Let's find out H2O2 moles. So H2O2 is 2 and second thing given is oxygen. So oxygen is 1, 2:1. For oxygen, they have given us the volume in centimeter cube. So let's first convert this into moles and this into minutes. So moles equals to volume in centimeter cube divided by 24,000 centimeter cube. So 180 divided by 24,000. So moles of oxygen is 0.0075. Now according to the ratio, we have 2:1, so we can find out moles of H2O2. If oxygen is 0.0075, we can cross multiply. So X will be 2 into 0.0075. So it is 0.0150 moles of H2O2. Now we have moles. We need to find out time in minutes. So we can convert seconds to minute by dividing by 60. So it's 1.5 minutes. Let's put these values in the equation. Moles of H2O2 is 0.0150. Time taken is 1.5 minutes. We can divide these two and answer is 0.01 moles per minute. So correct answer is D. Question number 10. Methanol is manufactured by reacting CO2 and H2 together. So we have carbon dioxide and hydrogen. The equation is given. Enthalpy change is negative. What increases the equilibrium yield of methanol in the process? So we have to look at this and the yield. First part is to increase the pressure. For pressure, let's look at the state, whether they are gases. All of them are gases. Now let's find out the number of moles. We have 1 mole of CO2, 3 moles of hydrogen. So 4 moles on the reactant side, 1 mole of methanol, 1 mole of water. So 2 moles on product side. When pressure is increased, the reaction or the equilibrium moves from more number of moles to less number of moles. So it will move in forward direction. So more methanol is going to be formed. This will increase the yield. Second part is adding an excess of steam. Steam is water. So water is one of the products. So at equilibrium, if product is increased, according to Le Chatelier principle, the equilibrium moves in backward direction to compensate that change. So when it goes backward, the yield of methanol will decrease. Third part is adding a catalyst. Catalyst does not affect the yield of any substance. It only decreases time to attain equilibrium. Last part is increasing the temperature. For temperature, we have to look at the type of reaction, whether that is exothermic or endothermic. This one is exothermic. For exothermic reaction, if temperature is increased, the reaction or the equilibrium goes in backward direction, decreasing the yield of products. So the only correct option is A. Question 11. The equation for the reaction of KClO3 is shown. KClO3 decomposes to form KCl and KClO4. Which row is correct? We have to find out whether it's a disproportionation reaction and the oxidation number of chlorine in KClO4. Okay, so disproportionation means self-oxidation reduction. If same element is oxidized as well as reduced, then it will be a disproportionation reaction. Let's find out the oxidation number. So we have K is +1 always. We have oxygen, it is -2. K is +1, oxygen is -2. Now chlorine is left. So let's find out chlorine. So in KCl, if K is +1, chlorine must be -1 because overall it's a neutral. Now let's look at KClO3. Overall the charge is 0. K is +1 and oxygen is -2. So 3 oxygen becomes -6. So chlorine -5. Chlorine will be +5. So we have +5 for chlorine. Now let's look at KClO4. Overall again it's neutral, so charge is 0. K is +1. Oxygen is -2, so 4 oxygen becomes -8. Chlorine -7 equals to 0. Chlorine will be +7. So from +5 to -1, which is a reduction. From +5 to +7, which is oxidation. So same element is oxidized as well as reduced. So yes, it is a disproportionation reaction. Oxidation number of chlorine in KClO4 is +7. So correct option is B. Question number 12. A student mixes 25 cm³ of 0.1 mole per decimeter cube sodium hydroxide with 25 cm³ of 0.1 mole per decimeter cube HCl and records a temperature rise of 2.5 degrees Celsius. What is the enthalpy change of the reaction per mole of sodium hydroxide? Okay, so let's find it out. Let's first find out the number of moles. Moles is same as volume and concentration is same for both acid and alkali. Moles equal to concentration into volume in decimeter cube. So 0.1 into 25 divided by 1000. Number of moles is 0.0025. Let's find out enthalpy change. For enthalpy change, we can use the formula delta H equals to minus mc delta T. M is the mass of solution, C is the specific heat capacity which is constant, delta T is the change in temperature. Let's put in values. Mass of solution is 25 cm³ of acid, 25 cm³ of alkali. So together 25 and 25 becomes 50. So 50 cm³ can be taken as 50 grams into specific heat capacity is constant 4.18. Delta T is the change in temperature 2.50. We do not have to change temperature to Kelvin because C has a unit of joules per grams per degree Celsius. 2.50 is also degree Celsius and this is grams. So grams cancels out with grams, degree Celsius with degree Celsius. The only thing that is left will be joules. So by calculation, enthalpy change is now equal to minus 522.5 joules. So this is for this equation, and in this equation we had 0.0025 moles. So this much energy is released for 0.0025 moles. So we have enthalpy change and moles minus 522.5 for 0.0025. In the question it says that you have to find out the enthalpy change per mole. Per moles is 1 mole. So for 1 mole it will be X. Let's cross multiply. So it is equal to 209,000 joules per mole. In the given options, we have 209 joules per mole, 522.5 joules per mole. These are wrong. So now we can convert the unit into kilojoules by dividing by 1000. Sign will be negative. Correct answer is going to be A. Question 13. Carbon monoxide and methanol can react together to form ethanoic acid. Equation is given. Standard enthalpy changes of combustion are given in the table. We have combustion for carbon monoxide, combustion for methanol, combustion for ethanoic acid, and everyone is 1 moles. What is the value for enthalpy change of reaction for the reaction between carbon monoxide and methanol? Let's find out delta HR by using combustion values. Let's write down the given equation. Carbon monoxide plus methanol forms ethanoic acid. Alright, so we have combustion for carbon monoxide, combustion for methanol, combustion for ethanoic acid. So for combustion we need oxygen. By combustion the product is CO2 and H2O. Let's put in the values. So for carbon monoxide combustion is minus 283. For methanol, combustion value is minus 726. As each one is 1 moles, so there is no change. Let's add these together. So we have 1009 kilojoules per mole. On the other hand, we have combustion of ethanoic acid minus 874.1. Okay, now let's draw the arrows. We have 2 tails starting from this point, so this is a starting point. 2 heads pointing this direction, so this is the end point. So we have direct route and we have indirect route. This will be delta HR. So in direct route we have minus 1009. It is equal to the sum of indirect routes, so delta HR and this one. We have to find delta HR. As this one is negative, it goes over there and becomes positive. So answer is minus 134.9. Unit for everyone is kilojoules per mole. So correct answer is B. Question number 14. Copper reacts with nitric acid under certain conditions. The products are copper 2 nitrate, water, and an oxide of nitrogen. 3 moles of copper reacts with 8 moles of nitric acid. What is the oxidation state of nitrogen in the oxide produced? Okay, they have given us the reactants and products. Let's write down the balanced equation. So copper reacts with nitric acid to produce copper nitrate, water, and oxide of nitrogen. Now we do not know if it is NO, NO2, NO3, N2O. So let's simply write NO and X and Y. Okay, now they have given the balanced values. So we have 3 moles of copper that react with 8 moles of nitric acid. Now let's balance the equation. There are 3 moles of copper, so we can write 3. Copper is balanced. Now let's balance nitrogen. We have 6 nitrogens on the product side, 8 nitrogens on the reactant side. So it means we need 2 more. So we can write 2 with NO. So that means that X will be equal to 1. Now we have hydrogens. So there are 8 hydrogens. We only have 2. So we can write 4. Hydrogen is balanced. For oxygens, we have 24 oxygens. 8 3s are 24. 3 2s are 6. 6 3s are 18. So we have 18 oxygens over here. 4 in water. So it becomes 22. We need 2 more. So it means there will be a 2 with NO. So Y is also equal to 1. So the formula of nitrogen oxide is NO. In NO, oxygen is minus 2. So nitrogen must be plus 2, as overall it's a neutral molecule. Correct answer is B. Question 15. All the reactants and products of an exothermic reaction are gaseous. Which statement about the reaction is correct? So it says the total bond energy of product is less than the total bond energy of the reactants, and enthalpy change for the reaction is negative. Then we have the similar one and it says enthalpy change is positive. Then enthalpy change is negative, enthalpy change is positive. So we have to find 2 things. One is the bond energy. Second thing is the enthalpy change. So let's suppose we have a chemical reaction which is exothermic. Let's suppose we have CH4, methane, reacts with oxygen, combusts to form CO2 and water. Enthalpy change is negative because the reaction is exothermic, as a lot of heat is also produced. So if the reaction is exothermic, enthalpy change is always going to be negative, not positive. Second thing is the bond energy of products or reactants. Let's see which one is more, which one is less. So for reactants, we always look at bond breaking. For products, we always look at bond formation. This is because the reactant bonds are broken and new bonds are formed in any chemical reaction. Now enthalpy change is negative. It means one of them is larger and one of them is smaller. Now always remember that bond breaking means the energy needed to break bond, so it is always positive. In bond formation, bonds are formed, so enthalpy change is always negative. Energy is always released when a bond is formed. So overall, the reaction is negative. It means the sum of these two is minus. The sum can be minus only if one of the value is less and one of them is greater. So let's suppose we have positive value of 800 and negative value of 1000. Now we can sum up these two and the ending result will be minus 200. So that's only possible if bond formation is more than bond breaking. Okay, let's look at part A and C. It says the total bond energy of products is less than the total bond energy of the reactants. Do not look at the signs, only look at the values. The value for products is greater than the value of reactant. Only then it can be exothermic. So bond energy of product is more 1000 than the bond energy of the reactants 800. So only then the answer will be minus 200. Correct answer is therefore C. Question 16. Propene, hydrogen cyanide and carbon dioxide each contains pi bonds. Which molecules contain 2 pi bonds? Let's write down the structure of all of them. We have propene. Propene is 3-carbon alkene. In 3-carbon alkene, we have 1 double bond. So we have 1 pi bond. All other bonds are sigma bonds. Second one is hydrogen cyanide. It is HCN. Nitrogen makes a triple bond with carbon. So now we have 2 pi bonds. Third one is carbon dioxide. Carbon makes double covalent bond with one oxygen and a double bond with another oxygen. So we have 2 pi bonds. The other ones are sigma. So both carbon dioxide and HCN contain 2 pi bonds and propene contains 1 pi bond. Correct answer is therefore A. Question number 17. Q, R and S are consecutive elements in period 3 of the periodic table. Element R has the highest first ionization energy and lowest melting point. What are identities of Q, R and S? Let's look at the melting point of all of them. So let's see which one has the lowest melting point in R. Okay, so first three are metals: sodium, magnesium, aluminum. Sodium has 1 electron in outermost shell. Magnesium has 2, so melting point increases. Aluminum has 3, so melting point further increases. So highest melting point is of aluminum and lowest is for sodium. So this one is incorrect. In second one, we have magnesium, which has 2 electrons in the outermost shell. Then aluminum has greater melting point. And silicon has giant covalent structure, so it has highest melting point of the whole period 3 elements. So aluminum melting point is not lowest. This is also incorrect. In third one, we have aluminum, silicon and phosphorus. So aluminum has lesser than silicon. Phosphorus is lower than silicon. So silicon has the highest melting point in this case. This is also wrong. The only correct option left is D. So let's see why melting point is lower, and let's see why it has the highest first ionization energy. In D, we have silicon. Silicon is giant covalent, so it has highest melting point. Phosphorus molecules are made up of 4 atoms. Sulfur molecules are made up of 8 atoms. So there are more intermolecular forces of attraction or more van der Waals forces in sulfur as compared to phosphorus. So phosphorus melting point will be low. Second thing is the ionization energy values. So let's find out about that for each of these. Atomic number of silicon is 14, phosphorus is 15, sulfur is 16. So we have 1s2, 2s2, 2p6, 3s2, and then in 3p we have 2 electrons. In phosphorus we have 3s2, and 3 electrons in 3p. In sulfur we have 4 electrons in 3p. Okay, so for silicon, as we can see, the atomic number is lower. So as atomic number increases, ionization energy also increases because size of atom will decrease further. So silicon has lowest ionization energy. Then if we look at phosphorus and sulfur, in sulfur we can see we have paired electrons. So there is something called spin pair repulsion. Due to spin pair repulsion, it is easier to remove this first electron because it is already being repelled by the other electron. So again we have lowest ionization energy. So what is left is phosphorus. So then there is no spin pair repulsion and atomic number is also higher than silicon. So it has highest ionization energy among these 3. This is first ionization energy values only. So D is now confirmed. Question 18. A reaction scheme for a group 2 metal M is shown. M reacts with oxygen, forms X, then reacts with water, forms Y, reacts with sulfuric acid, forms Z. Which row is correct as M descends group 2 from magnesium to barium? So we have to find out solubility of Y in water, solubility of Z in water. Let's find it out. So we have group 2 metal M. When it reacts with oxygen, it forms metal oxide. Metal is +2, oxygen is -2. When metal oxide reacts with water, it forms metal hydroxide. And when metal hydroxide reacts with sulfuric acid, it forms metal sulfate. Okay, so they are talking about the solubility of hydroxide and solubility of sulfates. So group 2 hydroxide, when we move down the group, solubility increases. That's why barium hydroxide is the most soluble. And on the other hand, if we look at sulfates of group 2, so down the group, solubility of sulfate decrease. That's why when we look at barium sulfate, it is the one that is least soluble. So down the group, solubility of hydroxide increases, and for sulfate it decreases. Correct answer is C. Question 19. U, V and W represent different halogens. The table shows the results of 9 experiments in which aqueous solutions of U2, V2 and W2 were separately added to separate aqueous solutions containing U-, V- and W- ions. This is the whole table. Which row contains the ions U-, V- and W- in order of their decreasing strength as reducing agents? So we have U2. When it reacts with U-, V- and W-, there is no reaction. V2 reacts with U-, reacts with W-, but it does not react with V-. W2 does not react with V-, does not react with W-. So we can see the first one does not react at all, second one reacts with 2, third one reacts with just 1. So from this we can infer that U2 is the least reactive, as it does not react with anyone. Then V2 is the most reactive among these three, as it reacts with 2 of them, and W2 is in between. So now we can rearrange them in order of reactivity, because for halogens we know that down the group reactivity decreases. So most reactive is V2. V2 should be at top. Then we have W2, which is in between. Then we have U2, which is at the bottom. Okay, so for negative ions we can write V-, W-, and U-. If we look at their comparison, so from group 7 we can take real ones. Let's suppose we have chlorine, which is more reactive than bromine, which is more reactive than iodine, and their negative counterparts will be Cl-, Br-, and I-. Now let's look at the reducing agent's strength. So reducing agent means which is itself oxidized or which gives away electrons. So among these three we can see iodide gives away electrons the easiest. So we can say that iodide is the strongest reducing agent. So as we can see, iodide is the strongest reducing agent. So we can say that down the group, reducing strength increases. So iodide is the strongest reducing agent, which is U minus. Chloride will be the weakest reducing agent, which is V minus. So correct option is B. Question 20. J is either magnesium chloride or aluminum chloride. K is either silicon dioxide or SiCl4. J, when we add drops of aqueous sodium hydroxide, it forms white precipitate, and when we add excess, then this precipitate dissolves. In K, if we add water, it forms misty white fumes and white precipitate, and a solution that has pH less than 7, so acidic solution. We have to identify J and identify K among these four. Okay, so let's start with J. J, aqueous. So it can be magnesium chloride or aluminum chloride. So in magnesium chloride we have Mg2 plus. In aluminum chloride we have aluminum 3 plus. When few drops of aqueous sodium hydroxide are added, it forms magnesium hydroxide, and this one forms aluminum hydroxide. Okay, so both are precipitates. Let's see what happens further. So when we add excess of aqueous sodium hydroxide, this is insoluble in excess. And this aluminum hydroxide solid is soluble in excess. So it means that as precipitate dissolves, so it should be aluminum. Second part is K, silicon dioxide or silicon tetrachloride. So let's add water in SiO2 first. SiO2 is insoluble in water, so there is no reaction. Second part is SiCl4. When this one is added to water, it forms silicon dioxide, solid, and fumes of HCl. So misty white fumes of HCl are formed. Because of these fumes, the pH is less than 7. So second part is silicon chloride. So AlCl3 and SiCl4. Correct option is A. Question 21. River water is an agriculture area, contains ammonium ions, carbonate, bicarbonate, chloride and nitrate ions. This water is treated by adding a calculated quantity of calcium hydroxide. What is precipitated from the river water when calcium hydroxide is added? Okay, let's see which ions do we have. So from calcium hydroxide we have Ca2 positive and OH negative. Calcium can make a compound with carbonate, so we have CaCO3. It can make bicarbonate CaHCO3. It can make chloride CaCl2. It can make a nitrate CaNO3. Ammonium can make hydroxide. Okay, let's look at the solubility. Calcium carbonate is insoluble. It is given as part B. Calcium bicarbonate is not given. Calcium chloride is soluble. All nitrates are always soluble. All ammonium ions are also soluble. All ammonium compounds. So this is soluble, this is soluble, this is soluble. The only thing left which is precipitated out is calcium carbonate. Question 22. 4 atmospheric pollutants are listed. nitrogen oxides, carbon monoxide, unburnt hydrocarbons, and sulfur dioxide. Which pair of pollutants react to form peroxyacetyl nitrate? To make peroxyacetyl nitrate, we need two things. One is volatile organic compounds, which can come from unburnt hydrocarbons, and nitrogen oxides. Together they make peroxyacetyl nitrate, the formula for which is CH3CO3NO2. Structure can be like this: CH3, C double bond O, 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 NO2. So 1 and 3 is the correct option, which is part A. Question 23. Which graph correctly describes a trend found in group number 17, where X represents a halogen atom? First thing is the bond length. We have chlorine, then bromine, then iodine. So it goes down the group. As we move down the group, size increases. This is because number of shells also increase. So when number of shells increase, the interatomic bond distance also increases. So bond length will increase. So it should be highest for iodine and lowest for chlorine. So A is wrong. B shows the strength of van der Waals forces. So we have chlorine. Chlorine is in the form of gas, and we have bromine, which is low boiling liquid. We have iodine, which is solid. So we can see that as size increases, number of shells increase, number of electrons increase. So due to increase in number of electrons, van der Waals forces also increase. So iodine should be highest, bromine lower, and chlorine the lowest. So B seems correct. Let's look at the other options. We have boiling point. So again, chlorine is gas, bromine is low boiling liquids, iodine is solid. So boiling point increases as intermolecular forces increase, while this trend shows decrease, so it is wrong. Then we have bond energy: HCl, HBr, and HI. So bond energy depends on the electronegativity and bond strength. So chlorine is the most electronegative, iodine is the least electronegative. So electronegativity decreases, bond strength decreases. So HCl should be highest and HI should be lowest. D is also wrong. Correct option is therefore B. Question 24. Gas M is produced when ammonium chloride aqueous is heated with calcium oxide solid. Which row is correct? Let's see, whenever ammonium salt like ammonium chloride reacts with the base calcium oxide, it forms salt, water, and releases ammonia. So gas M is not nitrogen, it is not nitrogen, it is ammonia. Let's find out whether it's a redox reaction or acid-base reaction. In redox, we have oxidation and reduction. So let's find out oxidation states. Simple one is Cl is -1, calcium is +2, oxygen is -2, +2, 1 chlorine is -1, 1 hydrogen is +1, 1 oxygen is -2. So there is no change in these oxidation states. Hydrogen is +1, +1. Nitrogen is left. Let's find out nitrogen. In ammonium chloride, which is overall neutral, we have nitrogen, we have 4 hydrogens, so it is +4, 1 chlorine, so -1. So nitrogen +3 equals 0, nitrogen is -3. In ammonia, overall charge is 0. We have 1 nitrogen, 3 hydrogens, so nitrogen is -3. So we can see there is no change in oxidation state of any atom, so it is not a redox reaction. It must be acid base. Now let's see, we have ammonium. In ammonium, nitrogen has 4 hydrogen atoms and it becomes ammonia when nitrogen has 3 hydrogen atoms. So 1 H plus is donated. So proton donor is acid. Calcium oxide is a base, so that's why it is acid-base reaction. So Bronsted-Lowry acid and base. Correct answer is therefore C. Question 25. Two nitrates decompose on heating according to the equations shown. We have lead nitrate, we have ammonium nitrate. Both of them decompose to form solid, gas, 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 and liquid. 1 mole of each nitrate is heated separately. The gas produced in each reaction is bubbled through sodium hydroxide. The volume of any gas that does not react with sodium hydroxide is then collected and measured. Which nitrate shows the greater percentage loss in mass? And which one produces the greater volume of gas collected? Alright, let's see. First thing is we have lead nitrate. It is solid, so it decomposes to form 2 moles of solid lead oxide, 4 moles of gas, and 1 mole of oxygen gas. We can find the percentage loss in mass by finding out how much gas is produced or how much MR difference is there. So we have lead nitrate and we have lead oxide. Lead oxide is still present after the reaction while gas is now evolved. So we can compare these two. We have lead nitrate and we have lead oxide. In equation there are 2 moles of each, so let's write 2. Now finding molecular mass, lead is 207.2. There are 2 nitrogens, 6 oxygens, 14 into 2 for nitrogens and 16 into 6 for oxygens. So molecular mass, it comes equal to 331.2. As there are 2 moles, so we can multiply it with 2. Now total molecular mass of the reactants is 662.4. Let's do the same for lead oxide. 207.2 for lead, 16 for oxygen. So MR is now 223.2. There are 2 moles. 446.4. Now we can find out the difference in molecular mass in terms of percentages. So 662.4 minus 446.4, it will give us the molecular mass that is lost in terms of gases. So this is the MR which is lost. We can also find out the percentage of the lost molecular mass. So percentage lost is equal to the lost MR divided by the total MR into 100. So percentage lost will be 32.6%. This was for lead nitrate. Let's do the same for ammonium nitrate. For ammonium nitrate, we can see that 2 moles of ammonium nitrate, they form gases, and 4 moles of water. So we can compare these 2 moles with the 4 moles of water. So ammonium nitrate and water, 2 moles and 4 moles. Let's find out molecular mass. So we have 2 nitrogens, 4 hydrogens and 3 oxygens. So it is equal to 80. Multiplying with number of moles, so MR is 160. In water we have 2 hydrogens and 1 oxygen, so it is 18 into number of moles, 72. Let's find out the difference. So 160 minus 72, 88. This is the molecular mass which is lost in terms of gases. Again, we can find percentage. So percentage lost MR divided by total MR into 100. So this one is 55%. So we have 55% for ammonium nitrate and 32.6% for lead nitrate. So greater percentage lost is shown by ammonium nitrate. Now second thing is the volume of gas collected. Let's see. Okay, now it says that each nitrate is heated separately, then gas produced is bubbled through sodium hydroxide aqueous, which is alkali. Now, alkali is something that can absorb acetic gases. So in our products, we have nitrogen dioxide, which is acetic gas. So this is absorbed by alkali. The volume of any gas that does not react. So we have oxygen, which does not react with alkali. We have nitrogen, we have oxygen, is then collected and measured. Let's find out which one produces greater volume of gas collected. So in first one, we have 2 moles of lead nitrate that forms 1 mole of oxygen. And in second case, we have 2 moles of ammonium nitrate and it forms 2 moles of nitrogen and 1 mole of oxygen. So we can see that 2 moles form 1 mole gas which is collected, and these 2 moles form 3 moles of gas collected. So we can say that ammonium nitrate forms greater mass of gas or greater moles of gas which is collected. Correct answer is therefore A. Question 26. Organic compound X has the empirical formula C2H4O. Compound X is reduced by lithium aluminum hydride but not by sodium borohydride. What is compound X? We know that lithium hydroxide is a very powerful reducing agent. It can reduce carboxylic acid. NaBH4 is also a reducing agent, but it cannot reduce carboxylic acid. So answer must be carboxylic acid. We have ethanoic acid. It is reduced by LiAlH4 only. We have aldehyde ethanol. It can be reduced by both to form primary alcohol, ethanol. Butane 1-ol is already primary alcohol, so it cannot be reduced further. Butanoic acid can be reduced by LiAlH4. Okay, let's see which one is the answer between these two. We can look at the empirical formula and molecular formula of ethanoic and butanoic acid. So ethanoic acid is CH3COOH. We have 2 carbons. Butanoic acid is CH3CH2 CH2COOH. So we have 4 carbon atoms. Butane is for 4. Ethane is for 2. So C2H4O2. And in this case we have C4H8O2. Let's simplify. So it becomes CH2O. And this one becomes C2H4O. It cannot be simplified further, so the one given in the question is this one, so that's why answer should be butanoic acid. Question 27. What is the mechanism of the reaction of hydrogen cyanide with propanone? So we have ketone and HCN. Propanone is 3 carbon ketone, CH3, C double bond O, CH3. HCN can react in this way. CN is a nucleophile. It will attack partial positive carbon. And these electrons will go to oxygen. Now we have CH3. CN is now attached to this carbon. Oxygen has full negative charge. This oxygen is now going to attack on hydrogen, and this CN is going to break the bond. End product is like this. We have CH3, COH, CH3, CN. And CN negative is formed again. So as the product is addition product, and at the starting point we had CN minus, which is a nucleophile, so it is nucleophilic addition. Correct answer is C. Question number 28. Which compound may be synthesized from an alkene with the formula C4H8 by addition reaction? In the products we have dibromo. So let's react bromine with this alkene. It is 4 carbon alkene, so it is butene. In butene, double bond can be between first and second carbon, or second or third carbon. You cannot make bond between third and fourth carbon because it is again similar to this one, as numbering will start from the right end. Rest are the number of hydrogens. Alright, now let's react it with bromine. So bromine is going to add itself on the double bonded carbons, one on each carbon, and double bond is going to convert into single bond. Okay, now let's name this one. We have 1, 2, 3, 4. On first carbon we have bromine, on second carbon we have bromine, so it is 1, 2 dibromo, and all are single bonds, so it is butane. 1 dibromobutane is not possible. Let's see what happens if we use this one. So again we have bromine. It will add itself to the double bonded carbons. Okay, now if we do numbering like this, the name will be 2,3 dibromo butane. 2,3 dibromobutane is not given. These are not possible. So the correct option is B. Question 29. The structure of compound G is shown. We have this compound. Compound G undergoes addition, polymerization. Which diagram shows the repeat unit of the polymer formed? Okay, let's see. For addition polymerization, there must be a double bond between two carbons. So we can see that these two carbons have double bond. So this is going to be the backbone of the polymer. Rest are the side groups. This CN is not going to be the part of long chain. This is not going to be the part of the long chain. Only these two carbons are present in long chain. So in order to make a bond, this pi bond is broken and one bond is formed on the left side, one bond is formed on the right side. So that will be the repeat unit. Let me draw this. We have CH2. I'm going to write it like this: CHH, double bond converted to single bond, and this CN is side group. This is also side group. A new bond is going to be formed on left side, a new bond is going to be formed on right side, and this shows the repeat unit. Alright, so let's see which one is the answer. In the first one, they have made this C double bond O the part of long chain, which is wrong. In second one, they have made CN part of long chain. In third one, CN is the side chain, CO2CH3 is the side chain, and we have single bond. In D, they have made long chain through CN, which is not possible. So the only correct option is C. Question number 30. Compound T is tested with 3 reagents and gives the results shown. We have 2,4-D and pH that forms orange precipitate. We have Phelan solution that gives no reaction. Acidified potassium dichromate gives no reaction. What is compound T? Alright, let's see. If we have 2,4-D and pH, which is dinitrophenylhydrazine, it forms positive, it gives positive results, or it forms orange precipitate with either aldehyde or ketone. Phthalate solution gives no reaction. No reaction means that it is not aldehyde, because aldehyde gives positive result with phthalate solution. So this is not aldehyde. Acidified potassium dichromate has no reaction. So acidified potassium dichromate can convert aldehyde into carboxylic acid, but it cannot convert ketone. So this means it is not aldehyde. So from this, the possible option could be ketone. Let's see what is given. The first one is CH3 whole 2 CHCHO. So we have CH3, CH, CH3 and C double bond O, H. As we can see, the functional group present here is aldehyde. So this is not the answer, because aldehyde can be oxidized by phthalate solutions and potassium dichromate. Second one, CH3, CH, CH3, CH2, OH. This one shows primary alcohol. Primary alcohol, it cannot form orange precipitate with 2,4-DNPH. Only aldehyde or ketone can do so. So this is also wrong. Third one is CH3, CH, OH, C double bond O, CH3. We have two functional groups. One is secondary alcohol, one is ketone. Secondary alcohol, it can be oxidized by acidified potassium dichromate into a ketone. So this is also wrong. Last one is CH3, CH, CH3, C double bond O, CH3. Functional group here is ketone. So all three results are positive with ketone. It can give positive result with orange 2,4-DNPH. It will not give any reaction with phthalate solution. It will not give any reaction with acidified potassium dichromate. So correct answer is D. Question number 31. Reagent X is added separately to 2-methyl-butane 1-ol and 3-methyl-butane 2-ol. Visible results are different. What is reagent X? So we have to find out whether it's sodium, alkaline iodine, PCl5 or acidified KMnO4. Let's draw these two. Butane means 4 carbons. Two methyl, on second carbon we have methyl group. 1-ol, on first carbon we have alcohol. Rest are the hydrogens. 3-methyl, on third carbon we have methyl group. 2-ol, on second carbon we have alcohol. Rest are hydrogens. Alright, now let's see what are the reactions with sodium first. Sodium can react with primary alcohol, it can react with secondary alcohol to form alk oxide along with hydrogen gas. So product formed will be CH2ONA. along with the formation of hydrogen gas. Similarly, for secondary alcohol, same reaction can happen. CH3, CH, ONA. Plus hydrogen. So both are same reactions, so it is not sodium because the visible results should be different. Second one is alkaline iodine aqueous. For alkaline iodine aqueous, we need CH3 bonded to carbon with secondary alcohol. So in this case, we can see we have CH3 bonded to CH and OH. So this gives positive result with alkaline aqueous iodine. We do not have any CH3 group and this is primary alcohol, so it does not give positive result with alkaline aqueous iodine. So this will form yellow precipitate. Alkaline aqueous iodine. The yellow precipitate will be of this group, which will later convert into CHI3. In this case, there is no such CH3 directly attached to this carbon, so that's why it will not give positive result. So we have yellow precipitate and we do not have any yellow precipitate, so it is visibly different. Third one is PCl5. PCl5 can react with alcohol and convert it into halogenoalkane. So instead of OH, we'll have Cl. Rest is same. Plus HCl and POCl3. For secondary alcohol, again, it will be converted into halogenoalkane. OH is going to be replaced by chlorine. Plus HCl and POCl3. So both are same reactions, there is no visible difference. Last one is KMnO4 acidified. So this is oxidizing agent. It can convert primary alcohol to carboxylic acid. So the first carbon will be converted into COOH. For this one, secondary alcohol is also going to be oxidized to a ketone. So in both cases, the color will be changed. For KMnO4, it will become colorless from purple. The only correct option is therefore B. Question 32. Compound Y is hydrolyzed by warm aqueous silver nitrate to form a precipitate that is soluble in dilute aqueous ammonia. Compound Y undergoes an elimination reaction to form an alkene. What is the skeletal formula of compound Y? In given options, we have bromine, iodine, chlorine, and chlorine. Okay, so when they are hydrolyzed by silver nitrate, they will form respective silver compounds AgBr, AgI, AgCl for these two. So AgBr, AgI for A and B, these precipitates are formed, and it says it should be soluble in dilute aqueous ammonia. But these two precipitates are not soluble in dilute aqueous ammonia. So it must be AgCl. So we have either C or D. Let's find out which one between C and D undergoes elimination to form alkene. So in C we have CH3, CH2, CH2, CH2 and Cl. Now for elimination, what happens? We have HCl removed. So from one carbon, chlorine is removed. From the adjacent carbon, one of the hydrogen will be removed, and there will be a double bond between these two carbons, and HCl is going to be removed. So product form will be CH3, CH2, CH double bond CH2 plus HCl. So it can form alkene. Now looking at D, we have CH3. In the center we have single carbon, CH3, CH3, CH2 and Cl. So we can remove chlorine from one carbon, but from adjacent carbon we can see there is no hydrogen atom that can be removed. So the reaction is not possible. Therefore D is wrong and correct answer is C. Question 33. Propane 2-ol can be converted into 2-chloropropane using reagent M followed by reagent N. Which row is correct? Okay, let's draw the structures. Propane 2-ol has 3 carbons. On second carbon we have alcohol. It can be converted to 2-chloropropane. So this OH is converted into chlorine. Now this is possible if we use HCl in the presence of acid, phosphoric acid. So OH will be converted into chlorine. You can also use HCl in H2SO4. So concentrated phosphoric acid and then followed by HCl. This is wrong. Chlorine can be used for alkenes. So correct answer is C. Question 34. Skeletal formula of 4 organic compounds are shown. 1, 2, 3 and 4. Which 2 compounds when separately heated with dilute sulfuric acid produce propanoic acid as one of the products? Okay, so let's draw the structures for this. So first one is CH3, CH2, C double bond O, H. So this is aldehyde. Aldehyde can be converted into carboxylic acid by oxidation. So this will need oxidizing agent like KMnO4, K2Cr2O7, etc. it will not form product with dilute sulfuric acid. So 1 is wrong. Second one is CH3, CH2, C double bond O, O, CH2, CH3. This is ester. It can be hydrolyzed by dilute sulfuric acid. It will break from here. This part is going to be converted into carboxylic acid, and this part will be converted into alcohol. So the product formed is CH3, CH2, COOH. This is one part of the product, and it is 3-carbon carboxylic acid, which is propanoic acid. So 2 is correct. Third one is CH3, CH2, CN. This is cyanide. It can be hydrolyzed in acid like dilute sulfuric acid to form respective carboxylic acid. So 3 carbons form 3-carbon carboxylic acid along with ammonium salt. So we have propanoic acid formed. This is also correct. Part 4 is CH3, CH2, CH2, oxygen, C double bond O, CH3. Again, this is ester, which is hydrolyzed. This bond breaks, this part converts to acid, this part converts to alcohol. So we have 2-carbon carboxylic acid formed. It is not propanoic acid, it is ethanoic acid. So incorrect. Correct answer is 2 and 3. Question number 35. 1-chloro, 2-methylpropane and 2-bromo, 2-methylbutane react separately with aqueous silver nitrate in ethanol. Both reactions proceed via nucleophilic substitution and a precipitate is formed. Time taken for 1-chloro, 2-methylpropane to form precipitate is T1. Time taken for 2-bromo, 2-methylbutane to form a precipitate is T2. Which row is correct? We have to find out the correct reaction mechanism. We have to find out which time is lesser and which time is more for precipitate to appear. So let's draw structures of these two. Compound 1-chloro, 2-methylpropane. On first carbon we have chlorine. On second carbon we have methyl. In total we have 3 carbons. Rest are hydrogens. Second one is 2-bromo, 2-methylbutane. On second carbon we have bromine. On second carbon we have methyl, and it is butane. Alright, so let's see which one follows which reaction mechanism. SN1 and SN2. Now SN1 is always followed by tertiary halogenoalkanes. SN2 can be followed by primary halogenoalkanes. We can see we have bromine and we have chlorine. So this bromine is attached to carbon, which is directly attached to 3 carbon atoms. So this one is tertiary halogenoalkane. So it follows SN1. So 2-bromo, 2-methylbutane will follow SN1. And this one has chlorine, which is attached to carbon, and this carbon is directly attached to only one carbon. So it is primary halogenoalkane. Primary halogenoalkane follows SN2. So B and C could be correct. Let's find out the time taken. So we have the reaction with aqueous silver nitrate in ethanol. So what will happen? This first one will form AgCl as one of the products, and this will form AgBr as one of the products, which means that carbon chlorine bond is broken in this one and carbon bromine bond is broken in this one. In halogen alkane, as we move down, size increases. For chlorine to bromine, the size will increase. Bond distance also increases, or bond length. But bond strength decreases. So it is easier to break CBr as compared to CCl. Alright, so this is easier and this is difficult. So it will take more time and this one will take less time. Let's see which one is which. So we have 1-chloro, which is T1. So for chlorine we have T1. And for bromine we have T2. So more time for T1 and less time for T2. So T1 should be greater than T2. This is only true for this case, so correct answer is B. Question 36. The diagram shows the structure of progesterone. This is the compound. Which statement about progesterone is correct? In these options, we can see all of them have mentioned chiral carbons and the molecular formulas. So let's find out the chiral carbons and molecular formulas. Remember that a carbon which is making double bond, a carbon which is attached to 2 hydrogen atoms, this is not chiral. A carbon which is attached to just 1 hydrogen, it is the most probable one that can be chiral. So chiral carbon is the one which has 4 different groups attached to it directly. So these 4 must be different. Let's see. So this carbon is making a double bond, it is not chiral. This is attached to 2 hydrogen atoms, it is not chiral. This is attached to 2 hydrogen atoms, so not chiral. This is making a double bond, so not chiral. This is making double bond, so not chiral. Let's see, this one, it is attached to CH3. This side and this side is different. This and this side is also different. So it is chiral. Moving further, this carbon is attached to 1 hydrogen atoms. And there are 3 other sides which are different from each other. So this is also chiral. This carbon is similar to this one as it is attached to 1 hydrogen, and this side is different from this one and this is different from that one. So chiral. This carbon is attached to 2 hydrogen atoms, so these are not chiral. 2 hydrogens, not chiral. This carbon is attached to 4 different groups, so it is chiral. Again, this carbon also has 4 different groups, chiral. 2 hydrogens with this one, 2 hydrogens with this one, so they are not chiral. This carbon has 1 hydrogen atom and 3 sides are different, so it is also chiral. This is CH3, so it is not chiral. This is CH3, so it is not chiral. This is making double bond, not chiral. This is CH3, so not chiral. 1, 2, 3, 4, 5, 6. We have 6 chiral carbons. Let's find out the molecular formula. It says C19 and C21. Let's find out number of carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 carbons, not 19. So correct answer is D. Question 37. A molecule of hexane can be cracked in a number of different ways. 3 compounds are listed. We have C3, C4, C5. Which compounds are found in the mixture of products from the cracking of hexane molecules? Okay, so hexane is 6 carbon alkane, C6, and there are 14 hydrogen atoms, as the general formula is CnH2n plus 2. So cracking means breakdown of this compound into various components. So we have C3H8. Let's see what is left. So 6 carbons, 3 are gone, 3 is remaining. 14 hydrogens, 8 are gone, and 6 are remaining. So C3H6, this is alkene, propene. So this one is possible. Second one is C4H8. So let's break it again. Let's see what is left. So from 6 carbons, 4 are gone, 2 are left. From 14, 8 are gone, so 6 is left. What is C2H6? C2H6 is ethane. So this is also possible. Now third one, C5H12. So from 6 carbons, 5 are gone, 1 is left. From 14 hydrogens, 12 are gone, 2 are left. CH2 is the second possible product. Now in CH2, carbon is not making complete 4 single covalent bonds. The minimum formula for carbon should be CH4. So this is not possible. First and second are possible, so answer is B. Question 38. The diagrams show the structure of two isomeric dicarboxylic acids, X and Y. X can be reduced to compound P with the empirical formula C2H5O. Y can be reduced to compound Q also with the empirical formula C2H5O. Which statement is correct? So we have to find out which one is cis and trans, and whether compound P and Q are identical or isomers. Okay, let's see. In the first one we have C double bond C, and second one we have C double bond C. Now we have COOH, COOH on same side, and hydrogen on same side. In this one, COOH is on opposite side. So X is cis and Y is trans. A and B could be correct options. Alright, now let's see the second part, which is the reduction to compound P with this empirical formula. Okay, let's reduce. Carboxylic acid can be reduced by LiAlH4. So carboxylic acid is converted into primary alcohol, CH2OH, CH2OH. Alright, now after reduction, let's see what is the empirical formula for this one. So we have 4 carbons, 8 hydrogens, 2 oxygens. So empirical formula will be C2H4O. This C2H4O is different from the one which is given, C2H5O, which means that further hydrogen atoms should also be added. So we can convert this double bond into single bond. It will become CH2, single bond CH2, and we have CH2OH, CH2OH. Now we have 4 carbons, C4, 10 hydrogens, 2 oxygens. So now empirical formula is C2H5O, which is similar to the one which is given. Let's do the same for this one. Reduction. Primary alcohol is formed. Again, as this is isomeric, so same molecular and empirical formula will be there, which is not correct. We need to make it C2H5O, so we can further add hydrogens as we did in that one. So CH2, CH2, CH2OH, CH2OH. Now we have 4 carbons, 8, 10 hydrogens, 2 oxygen. So it is C2H5O empirical. Alright, so first part is done. Both are cis, X is cis. And second part is whether P and Q are identical or isomers. That depends on the naming of P or Q. Okay, let's look at this one. We can start numbering 1, 2, 3, 4 as it is long chain. So on first carbon we have alcohol, on fourth carbon we have alcohol. So we can write 1,4-diol. And the rest part is 4 carbon. So it is butane. So butane 1,4-diol. Alright, let's do the same for this one. Numbering 1, 2, 3, 4. On first carbon we have alcohol, on fourth carbon we have alcohol. There are 4 carbon atoms in between. So again it is butane 1,4-diol. So if name is same, it means that this is not isomers, it is actually the same compound. So they are identical. Correct answer is A. Question 39. What is the total number of sp3 hybridized atomic orbitals used in bonding of but2-ene? Let's draw the structure of but2-ene. On second and third carbon we have double bond. Rest are the number of hydrogens. To simplify, the carbon that makes 4 single bonds is sp3 carbon. The carbon that makes one double bond, two single bonds is sp2 carbon. This is also sp2. This one is sp3. They're not talking about sp3 carbons or sp2 carbons. They want to ask about sp3 hybridized atomic orbitals. So each carbon atom has atomic number of 6. What happens that in ground state we have electronic configuration 1s2, 2s2, 2p2. 2p can be further divided into 2px, y and z. So there are 2 electrons. Now what happens is that according to this one, there are 2 unpaired electrons, so carbon can make only 2 bonds, but in reality carbon makes 4 bonds. So this is possible by hybridization. In hybridization, carbon atoms goes from ground state to excited state. And in excited state, what happens that one electron goes from 2s into 2p. This is possible when all these 4 orbitals mix together. So by mixing of 1s and 1s does not mean this one, 1s means single s orbital and 3p orbitals. So 1 s orbital and 3p orbitals mix to form 4 sp3 hybrid atomic orbitals. Alright, so let's see. 4 sp3 hybrid atomic orbitals are made by one carbon. So it means this carbon has 4 hybridized atomic orbitals, and this carbon also has 4 hybridized atomic orbitals because these 2 carbons are sp3 carbons. sp2 mixing is different. In that one s orbital and 2p orbitals mix together. So 4 for this carbon, 4 for this carbon. In total there are 8 sp3 hybridized atomic orbitals in this whole molecule. So correct answer is D. Question 40. Compound L contains carbon atoms. It is analyzed in a mass spectrometer. The table shows the relative abundance of the only 2 peaks recorded with mass to charge greater than 127. We have mass to charge at 128 and mass to charge at 129. Relative abundance is 50 for this one and 5.5 for this one. How many carbon atoms are present in one molecule of compound L? Alright, so this 128 and 129, it can be referred to as molecular ion peak. So this is M positive and this is M plus 1. It can be because of carbon 13 isotope. Okay, now let's write down the formula that can be used to find out carbon atoms. So number of carbons is equal to 100 divided by 1.1 into abundance of M plus 1 peak divided by abundance of M plus peak. Let's put in the values. 100 by 1.1 into this is 5.5 and this is 50. So this comes equal to 10. So there are 10 carbon atoms in this compound L. Thanks for watching. If this was useful, please do like, subscribe and share.